All right, geometry fans. This is Mr. Knight. Mr. Durant is not available today, so we got a quick lesson for you for units or section 5.3. All right, so in your notes you can turn to page 16. Today what we're going to do is we're going to investigate a way to prove that triangles are congruent. In your last lesson 5.2, we saw how polygons can be congruent if all the sides are congruent and all the angles. But what if we have two triangles? How can we show that they are congruent? All right? So here I got a triangle, and here I got another triangle somewhere like this. Okay, how do we know that those are congruent? Well, we're going to find some shortcuts here, all right? And to do that, we're going to look at a Geogebra example here. So let's get that going. Here I've got a triangle right here. And on this triangle, right now, we've got it set to 40 degrees, okay? So that angle is at 40 degrees. And notice we've got this triangle right here. That's a circle, actually. That circle has a radius of 2, okay? So this distance right here has to be 2, no matter what, because that's the radius. That's what a radius means, all right? Here we got a circle that has a radius of 3. So this point right here gives us a line segment that's going to have a length of 3. All right, so what we're going to do is we're going to build a triangle, and we want to find out if it is a certain size or not, okay, if it is different. So we're going to set part of the triangle to be congruent, and that is this. I want to have angle A equal to 40 degrees, okay? I want that always to be true. And I want, this is point B here, I want B and AB, to be 2 units. Okay, that's this length right here. And I want this length here to be 3 units. And that has to be, that AC, that has to be 3 units because it's stuck to the circle there, all right? All right, so the question I have is, if those things are true, what will the triangle look like? Can it look like different things, or is it only going to look like one certain thing? Well, let's find out. Right now, what we're going to do is we're going to measure the length from B to C. And so we notice BC is 1.95. Okay, so right now I have it set up just like I have it, and BC is 1.95. All right? I can also measure some angles if I do that real quickly here. No, I don't want that. Let's go the other way around. We want to measure this angle right here, and that's a 98.79. So angle B, right now, the measure of angle B is 98.79 degrees. All right, and then this angle right here, angle C, is hard to read. Let's bring that. That's 41.21. Okay, so measure of angle C is 41.21 degrees. All right. So again, I'm going to set these to be true, and I want to know what the resulting pieces are. All right, so let's try that. So let's tweak this. I'm going to just swing this around. There's a triangle. It has 129 down here. We don't want 129. So I'm going to change this until we got it to be 40 degrees. Let's see. I'm going to set it to be 40 somewhere. Let's see if I can get it dialed in there. 40 degrees. And there it is. Oh, and it changed. Come on, 40 degrees. Stay. There it is. Okay, so we got 40 degrees. So the question is, what's our triangle look like? Oh, well, what do you know? The triangle's in a different spot. We've got 40 degrees. Okay, we set that. This is 2 because it's stuck on the circle. This is 3. Oh, look, the other side is 1.95. Check. All right. This angle right here is 98.79. Check. This angle up here is, what do you know, it's 41.21. Check. So the angle I have right now is congruent to the angle we had a few seconds ago. All right? And so, is that always going to be true? If I set this to be 40 degrees and 2 and 3, will I get that same exact triangle? I don't know. Let's find out. Let's go down here maybe. Let's find some triangle down here. I'm going to try to set that to be 40 degrees. Let's see if we can lock it in there. 40 degrees, 41, 40, and there it is, 40 degrees. All right, so we locked it into 40 degrees. Angle A is 40 degrees. That's what we were supposed to have. This is 2 units long because it's on that circle. Okay, this is 3 units long because it's on the larger circle that has a radius of 3. And when we set that to be true, well, what do you know? BC turns out to be exactly 1.95. Check again. And our other angle here, we got the angle C. It's 41.21 down here. Check. And the other angle, hiding in here somewhere, is going to be 98.78. Check. So it's exactly the same. So what does that mean? That means no matter where I build a triangle, if I have these 2 sides and an angle in between them, let me actually move this around because this angle is actually right in between these 2 sides. See this angle right here? It's made by these 2 sides. So here we have an angle between 2 sides. Okay, so I've got a side, an angle, and a side. We set those to be a certain size, and the rest of it fell into place. The triangle is congruent. All right? So, with that there, we know that if we set 2 sides congruent and the angle in between, that they will be congruent. Flip a couple pages, you have this slide right here. This is what we call the side angle side congruence theorem. All right? So, here's how the congruence theorem goes. If I have one triangle that has a side that is congruent to a side of the other triangle here, okay? So these 2 sides are congruent. That's what the marks tell us. And we have another side of the triangle that's congruent. And we have the angle in between it. We know that that angle is congruent. Then those 2 triangles have to be exactly the same. Now notice we didn't tell you anything about these other sides. We don't need to know about that side. We don't need to know about the other angles in there. I don't care about those things. All right? So we just need to know that 2 sides and 1 angle is congruent. That's enough. We call this the side angle side congruence theorem. All right? Flip the next page. Let's put it to practice. Okay, so here's how it goes. We're going to do a little proof. We've got some given information. DC is congruent to DA. All right? So BC, that's marked as congruent to DA. And we know the lines are parallel like it says here. Okay? So we want to collect some information. We know that BC is congruent to AD. All right? That's one side. Do we have any angles that are congruent? Well, we've got parallel lines, so that angle right there, what's that have to be congruent to? Do you see it? Do you see the alternate interior angles? There it is, okay? So we have angle BCA, that's congruent to angle CAD, all right? And so that gives us an angle that's congruent. Okay, this was a side that's congruent. All right, and we need another side. Well, what's the other side that makes up this angle? It's this guy right here. And notice AC. Let me highlight this here. AC. Think about AC in this triangle. We got a triangle right there, and AC is part of that triangle. Well, tell me this. What's bigger, the AC in the green triangle or this side that we can call AC in the white triangle? Well, obviously they're the same thing, okay? So AC that's in the top triangle is the same as AC that's in the bottom triangle. So we can say this. we can say that AC is congruent to AC. That's another side, okay? And it's kind of obvious, okay? It's almost too obvious. Makes us cry, it's so obvious. We have a reason for this. This is the reflexive property, okay? Reflexive property. And the reason for this guy right here, this was given. And the reason for this thing, these were alternate interior angles, okay? Now, so the question is that enough to say that the triangles are congruent? It absolutely is. Okay, we've got our side, we've got our angle, we've got our side, okay? And so that's enough. So the triangles, let's write a congruent statement. Triangle ABC is congruent to triangle CDA. And we've got to make sure those are in the right order, and they are because we were given those, okay? All right, so there's a proof. We didn't write that as, I got to have a reason here. Okay, this is by, and we say side, angle, side. Okay? So if we wanted to put this in a two-column proof kind of idea, like we've done before, all we need to do is take these guys, move this over here, given alternate interior angles, and a little reflexive property, two-column proof. There you go. All right? So we've got our statements, we've got our reason, we've got to have these three things, two sides, an angle, and a side, and then we can say the triangles are congruent. That's how we use this thing, okay? Here we've got another one. Let's flip to the next page there. Okay, here we've got in a circle, okay, we've got QS and RP. They pass through the center M. Okay, we want to know what we can conclude about these triangles. Well, let's think about it. First of all, it's in a circle. So we've got a bunch of radiuses. This length here is a radius. This length here is a radius. This length here is a radius. And another radius. Got a bunch of radiuses. And what do we know about radiuses in a circle? Well, they're all congruent. So these guys are all congruent there. All right? So we can say that RM is congruent to MP. All right, I'm picking one side from one triangle and one side from the other. Could I have picked MQ? Sure, why not? But I didn't. So we've got SM. Whoa. Let's see. We've got, we also have SM is congruent to MQ. Okay? Any angles? Do we know any angles that are congruent? We sure do, right? We got some vertical angles. There they are. There's some vertical angles. So we've got angle SMR is congruent to angle PMQ. All right? And those are vertical angles. Okay? These sides we can say because they're radiuses, and radiuses are congruent. All right? Congruent radiuses, something like that. All right? All right. And so that's enough. We've got a side, and this angle is included in those two sides. It's made by the side, so we can say triangle MRS is congruent to triangle M. That's not an M. Triangle MPQ. And the reason by side, angle, side theorem. That's the big idea. Side, angle, side. Two sides and the angle that's in between them. All right? All right, one more little problem here. Okay? So we've got these triangles on a barn. Hard to see a little bit there, so let me highlight those things. We've got this triangle here on a barn, and we're told that these are 90 degrees, all right? And so here's our information. You're making a canvas sign to hang on the triangular portion of the barn wall shown in the picture. You think that you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS. That's what we just said with those 90 degrees. And PQ is congruent to PS, all right? So PQ, well, P, you can't see P, there it is. PQ is congruent, so that's congruent to PS. So we can label those, all right? Use the side angle side theorem to show that these triangles are congruent. So I've got two triangles, okay? This little guy here and this little one there. We want to say that those are congruent. They sure look congruent. We know that, let's do this as a proof here, okay? We know that QP is congruent to PS. That's given. That's in that information. We know that angle QPR is congruent to angle SPR. How do we know that? Well, because they're right angles, and right angles are congruent. Okay? Right angles are congruent. All right? Uno, dos, tres. Okay? And we know also that RP is congruent to RP. Whoa, how do we know that? Well, RP is the same thing as itself. And this is that property we talked about a moment ago. Notice RP is in both triangles, and so we've got to use that, and it finishes off that angle. We want to have this angle here, and so we need to talk about both sides of that angle. And so we have that, and that is the reflexive property. All right? Reflexive property. And then last but not least, okay, our conclusion. So we have two sides and an angle in between them. The triangle PQR is congruent to triangle PSR. And the reason for that is the reason of the day, side, angle, whoa, side, angle, side. Okay? That's how you use side, angle, side. Got to be able to show two sides and the angle that is in between those two sides. All right? One last little thing here is this. What if we have two triangles like this? Okay? And if I tell you that we've got this guy and, okay, okay, let's say that we tell you that we've got, let's straighten this out. Okay, I've got this side's congruent to that side. This side is congruent to this side. Okay, and I'm going to give you an angle. There's an angle right there, and there's an angle right there. Okay, is this side angle side? Think about that. Side, angle, side. Do we have two sides that are congruent? Two pairs of sides? Well, we sure do. Okay. We've got two sides. We've got this one's congruent to that one. We've got this side congruent to that side. So we've got two sides and we have an angle, but what's the problem here? This angle is not between these two sides. Okay, so the angle we know is not included by the two sides. The two highlighted sides don't make this angle. So, no. Okay, if we wanted to call something, this is two sides and an angle that's not between the sides. Notice, we need this angle between the sides, but it's not. All right? And so this is side-side angle, and, okay, spoiler alert, side-side angle doesn't prove triangles congruent. All right? Okay. So you can't use side-side angle, or don't call it angle side-side. That's bad news, okay? So you can't use it if the angle is not between the two sides, okay? So watch out for that. Side, angle, side is like this guy, where the angle is between the two sides. All right? So let's put that into practice. Good luck, guys.